All right, welcome to the last part of section 5.3. Let's actually use these determinants to do something useful. So one of the ways we use determinants is with a method called Cramer's rule, which is another way to solve a system of two equations. And so we can use substitution, elimination, an augmented matrix, and now we have a fourth way of doing it called Cramer's rule. So it's a little tricky at first, but it's once you get the like with all things, once you get the hang of it, it's not that bad. Here's the key idea. We solve x and y based on some determinants that we make off of the system of equations. So to use Cramer's rule, your system of equations needs to look like this, okay? It needs to be like you would do elimination. So it needs to be set up like you would use elimination with everything lined up. The first thing you do is you make a matrix of just the variables. So 8, 2, 8, 5. Okay? So do you see how I did that? Just the coefficients of the variables. And then we find the determinant of that. And I call this determinant of v, because v for variable. So let's do that. 8 times 5 is 40, minus 16 is equal to 24. Okay? So 40 minus 16 is equal to 24. Now that's v. So the next thing we do is we make another one, and I'll call this x. Okay? So determinant of x. And the way we do this is we take the v, but instead of the x's, we put the answers in. So we replace the x's with the answers, 12, 42, and then the y's stay the same. Okay? So hopefully you can see what I did there. I just replaced the x's with the answers. So let's find this determinant. So 12 times 5 is 60, minus 2 times 42, which is 84. So that's equal to negative 24. And finally, we do the determinant of y. And again, I kind of came up with these names to help me remember how to do this. You might see other teachers or other books or something do it slightly differently, but this is how I do it. So kind of like with the x's, this time we replace the y's with the answers. So it's 8, 8, 12, 42, like that. So that time for the y, we replace the y's with the answer. So 8 times 42 is 336, minus 8 times 12, I believe, is 108. Nope, just kidding, it's 96. So it's 336 divided by 96, which is 240. Okay, so we got the determinant of the v matrix, the determinant of the x, and the determinant of a y, and we're almost done. Because if you look, when we solve this system, x is just equal to this divided by this, and y is just equal to this divided by this. So x equals the determinant of x, which was negative 24, divided by v, the determinant of the v matrix. So x just equals negative 1. That was easy. Now y. Y is just equal to the determinant of y divided by the variable determinant. So that would be y equals 240 divided by 24. And so y just equals 10. So the answer is x equals negative 1, y equals 10, or negative 110. And that's it. That is how to use Cramer's rule. So you just find the determinant of the variables, the determinant of x, replacing x's with the answers, the determinant of y, replacing y's with the answers, and then in the equation, x is equal to this number over this number, y is equal to this number over this number, and then you're done. In fact, if you were to use a computer program to try to solve systems of equations, it would probably use Cramer's rule, because this would be pretty easy to just write into a simple computer program. Okay, now let's do this system of equations. So the process is exactly the same. Notice first that the x, y's, and answers are all lined up. So the variable matrix is negative 11, negative 4, negative 10, negative 10. That times that is positive 110, minus negative 10 times negative 4 is positive 40, so it's minus 40. So that equals 70. For the x, we just replace the x's, 36 and 20, -4, -10. Just like that. So -360, that times that, minus this times this. That times that is -80, so it'll be +80 because it's minus -80. So you want to get to a place where you can do these determinants in your head. So 360 negative plus 8t equals -280. There you go, -280. All right, and finally the determinant of y is going to be keep your x's and replace y with the answer. Isn't it cool that this works? So -220, I believe, is 11 times 10. Oops, I mean 11 times 20 is 220. So -220 minus, which will turn into a plus 360. And that is going to equal 140. There you go. So we got our three numbers, and so now we can just find x and y. So x equals 280 over 70, which equals 4. Y equals 140 over 70, which equals 2. And then you're done. So there's x and y, for example, too. So that's kind of a cool method if you want to just memorize it and use it when you notice it. It's nice because it uses determinants, and 2x2s are not that hard to calculate. Which brings us to this. So in the homework, there's a problem where they want you to use Cramer's rule to do a 3x3 matrix and to solve a 3x3 system. And here's the honest truth. It is very complicated and long. And you end up, there is a way to do it with a Cramer's rule for 3x3, but it's very long and you have to do a whole bunch of 3x3 determinants. And so my recommendation is, and I know I'm not supposed to say this because I'm a math teacher, but don't use Cramer's method. It's too long, and I mean, go ahead and try if you want to look it up on Wikipedia, look up the formula, look up Cramer's rule, and I think they have a formula for 3x3. But my recommendation is to just do what we did in section 5.2 and use Gaussian elimination and an augmented matrix to solve it, because otherwise it's really long. So if you want to give it a shot, go for it, but you won't hurt my feelings if you just solve it with Gaussian elimination. One last example, and then we are done with this section. So we want to solve for x, and this is what they give us. So is this even possible? We can't find a determinant if there's x in here. I mean, we could find the determinant, but it won't be a number. It'll have x in it. But because this is equal to 1980, we can actually solve for x by calculating the determinant and then just setting it equal to 1980 to see what value of x makes this matrix have a determinant of 1980. So let's put in our helpful diagram, which you need to memorize. It's not that hard to memorize because it's just plus, minus, plus, minus, plus. Which row do you recommend we go through, or column do you recommend we use to do this? I would recommend either going across the second row or going down the first column. That would be my recommendation. So let's go, I'm going to go ahead and go across the second row because there's less negative signs. So let's do that. So again, we're doing that because we have that 0 right here, so that makes life easy. So it's going to be our first is a -0 times smiley face, because we don't even need to calculate that because we know it's going to be 0, plus, and remember that's the determinant of smiley face, plus 8 times this determinant. We ignore this row, this column, and this row, so it's just the 4 corners. -3, -2, 5, and x. And then our diagram says minus 7 times, ignore this and ignore this, so it's -3, 5x. Again, we're ignoring this, -3, 5x, 5, -3. Okay, That goes away. This will be 8 times, now be careful here, it's this times this, which would be negative 3x, is minus 5 times negative 2, which is negative 10. So it'll be minus negative 10, which is plus 10. Minus 7 times negative 3 times negative 3 is 9. Minus that times that is 25x. And by the way, remember, this is equal to 1980. And that's why we're going to be able to solve for x. Okay? So now we just need to solve this equation. So distribute negative 24x plus AT minus 63 plus 25 times 7, which I think is 175. Yep. X. Negative 7 times negative 25 is 175x. All of that equals 1980. So let's do this. Combine like terms, combine like terms. So we get 80 minus 63 is 17. 175 minus 24 is 151. Now we subtract 17 and subtract 17. 1936. And then just divide by 151. So x equals 1963 divided by 151. And we get 13, a very lucky number. So x equals 13 is the answer. So I hope you enjoy using determinants. I think they're kind of fun. And you can see that they're useful for solving a 2x2 system, but really they have dozens of uses, and we're only just scratching the surface. You'll learn more about matrices in a class called linear algebra, and you'll discover that they can be very, very useful. All right, especially in engineering. All right, so just to close this out, let's see what this would have been. It would have been 5x negative 2 negative 3x. But again, that's times 0, so it's just 0. I hope you enjoyed this video. If you did, please like and subscribe, and I will see you in the last, or actually it's not the last, the second to last section in Chapter 5, which is 5.5, and I will see you there.